In this module, we will discuss how to ensure that your temperature measuring equipment is working properly. Achieving a specific temperature is a critical step for killing bacteria in many food processing operations. For example, milk needs to be pasteurized by heating it to 161.6 degrees Fahrenheit for 16 seconds to make it safe for the public to consume. Raw materials, work in process, and finished product will need to be kept cool enough so there is no danger of microorganisms growing. Entire production areas and warehouses may need to be monitored, as will shipping trucks. Many products need to be cooled from a high temperature. You'll need to monitor that process to ensure that cooling is quick enough for food safety. It's really important that the thermometers you use are accurate. The process of ensuring that your thermometers are giving you the right information is called calibration. In this module, I'm going to show you how to check that and calibrate them when necessary. We will discuss the different types of simple thermometers that are used in food processing operations, how to determine the frequency of calibrations, corrective actions to take when a thermometer is found to be out of calibration, and how to document your procedures and what records should be kept. Different applications require the use of different thermometers. I have here a wide array of thermometers that can be used for different applications. The first one is an inexpensive thermometer that cannot be easily calibrated, so it is not suitable for use in the food industry. This next one is a little more expensive. It is also a dial thermometer, but its advantage is that it can be calibrated. So you can take a little wrench and turn this nut at the bottom to adjust the calibration so that it does read correctly. This next one is an infrared thermometer. It has a digital readout which helps eliminate human error, and it is great for measuring surface temperatures or things that are a little difficult to reach because you just aim it at the point at which you want the temperature taken. It also is available with a probe attachment which you just connect, and then you can use it to measure internal temperatures of products. This is a probe thermometer. It also has a digital readout, the same as our laser thermometer, which removes some of the human error in reading a dial thermometer. It's much more precise. This is used for taking internal temperatures. So we may use this to take the temperature in a kettle or in a food product. Then we have a thermometer that is really great for measuring stationary things, such as the inside of a fridge or a cooler. You simply place the end of the wire into a liquid of glycol or other solution because that makes it more accurate than just having it loose in the air. And again, it has a digital readout which is nice and large. Another thing on this that is important is that the label indicates the date that it was calibrated. It has a unique inventory number. It has the date that it was calibrated, the date that we need to calibrate it again, the deviation of 1.4 degrees, which means that it reads 1.4 degrees higher than we would expect, and who verified it. This information may be recorded on the label as shown here or in a calibration log. And our last thermometer is a NIST certified mercury in glass thermometer. This has been one of the standards in the food industry for years, and it is used most often to calibrate other thermometers. It comes calibrated with a serial number and a calibration certificate. If you have one of these, then calibrating your other thermometers that you use in your operation out on the floor becomes really very simple. So now we're going to look at how to calibrate a thermometer. It's common knowledge that water boils at 100 degrees Celsius or 212 degrees Fahrenheit and freezes at 0 degrees Celsius or 32 degrees Fahrenheit. This is used as the basis for calibration techniques. To determine if your thermometer is reading the freezing temperature correctly, you need to add some ice to cold water and allow it to equilibrate. Ensure that there is some ice remaining in the ice bath and insert the thermometer so that the end does not touch any ice. If corrections are required, you'll just need to follow the instructions that should have come with your thermometer. As I mentioned before, if you have an NIST certified mercury in glass thermometer, your job is even easier. If the thermometer that you have reads the same as the NIST thermometer in both freezing and boiling water, your thermometer is reading correctly. We've been calibrating these thermometers in a plant in Vancouver at sea level. But for every 500 feet above sea level, water boils at nearly 1 degree Fahrenheit less. So in Calgary, which is 4,000 feet above sea level, water boils at 205 degrees Fahrenheit or 96.3 degrees Celsius. So it's important to find out the altitude of the plant where you work and calibrate your thermometers accordingly. If they are only out a degree, there's no worry, but more than that, you need to recalibrate your thermometers. There is a link to a sample calibration procedure that you can download and customize for your own operation. Some labs in food processing plants have calibration machines. Here a probe thermometer has been inserted and it has to reach a temperature of approximately 71.1 degrees Celsius in order to be considered a properly calibrated instrument. This thermometer reaches 71.0 degrees, which is within the acceptable accuracy range. So what do you do if your thermometer is not reading the correct temperature? Well, it depends. First, you would calibrate it and determine how much the readings are off. If the thermometer can't be calibrated, you need to discard it. But regardless, you need to consider the impact on the safety of the food. If the thermometer is out by a degree or so, the food is probably safe because there's a safety factor built into most food processes. If it's not considered safe, you would put the product on hold and conduct a food recall. A question I get asked is how often should a thermometer be calibrated? There's several things to consider. Firstly, the importance of the measurement. Is it a regulatory or food safety measurement, or is it done for quality purposes? Secondly, the stability of the thermometer. Does it easily become out of calibration? And thirdly, its sensitivity and precision. You won't be able to fine-tune one that is not very precise. Electronic monitoring devices are usually quite stable. It's common practice to have outside specialists come in once or twice a year to calibrate milk pasteurizers or canning retorts. The less expensive handheld thermometers need to be calibrated weekly or monthly. If your temperature measurements are critical, you need to calibrate more often. In this module, you have seen different types of simple thermometers that are used in food processing operations, how to determine the frequency of calibrations, corrective actions to be taken when thermometers are found to be out of calibration, and how to document and record your actions using sample procedures. You might want to look at the related module in this series on how to take temperature measurements. If you would like to test your knowledge about thermometer calibration, take the test below. Don't worry, you can review this module and repeat the quiz if you need to. To receive a certificate of completion, you will need to complete the quizzes in all of the modules in this series. Good luck! See you in the next module.